Suppose a future mission finds simple life beneath the ice of Europa. That would be one of the greatest scientific discoveries in human history. But in the logic of the Great Filter, it might carry an uncomfortable implication. If life begins independently in two places within one solar system, then the origin of life may not be the rare step. Suppose we later find complex multicellular fossils on Mars, or evidence that life arose on many nearby worlds. Each discovery would suggest that another early step is common. That would push the unknown filter farther down the path, possibly toward intelligence, technology, or survival. This does not mean discovering alien microbes would actually predict human extinction. The probabilities are too uncertain, and the assumptions are too simplified. But the idea reveals why the Fermi paradox is connected to our future. We are not only searching the sky for other civilizations. We are trying to understand whether civilization itself is a stable phase. Look at the powers humanity gained in a very short time. In a few centuries, we learned to reshape landscapes, alter the atmosphere, split the atom, and modify genes. Our wisdom did not grow at the same speed as our tools. We still make decisions using minds shaped for small groups, immediate threats, and short-term rewards. The danger may not be one particular technology. The danger may be the gap between what a civilization can do and what it can responsibly control. Nuclear war is one example. Environmental collapse is another. Engineered pathogens, uncontrolled autonomous systems, and other risks could also threaten a society. And some may become more dangerous precisely because civilizations are connected. A system can spread resources, but it can also spread failures. Still, the Great Filter should not be treated as a prediction. It is a framework. There is no scientific evidence that all civilizations destroy themselves. Humanity is the only test case we have, and our story is not finished. It is also possible that advanced civilizations become more stable over time. They may learn to manage planetary systems and distribute themselves across multiple worlds. Technology creates risks, but it can also create defenses. Telescopes can find asteroids. Medicine can stop diseases. Clean energy can reduce environmental pressure. Knowledge can be preserved. The same intelligence that creates a filter may also recognize it. Perhaps the transition from a short-lived civilization to a durable one is not impossible. Perhaps it is simply difficult. That distinction matters. An impossible barrier means the silence is our fate. A difficult barrier means the silence is a warning. And warnings can be useful. The silence may be a warning, not a verdict. But before we decide the universe is full of ruined civilizations, we should consider a much less dramatic explanation. Maybe no one is missing. Maybe we simply have not looked properly.